Welcome to the Probability and Statistics course. Today's lesson is on hypothesis testing for one sample. Now, in our previous two lessons, we talked about confidence intervals. We also talked about when we have some questions to answer, and we said that we are going to see how, using statistics, we can answer these questions. That's what this lesson is about. It's about asking questions and answering them using statistics. So, what we are going to see in this lesson is hypothesis testing for one sample. As we have seen with confidence intervals, we are going to see separate when we have two populations, when we have two samples from two populations, and when we have one sample from one population. In this lesson, we are going to work with one sample. We are going to see how to do hypothesis testing for the mean, for proportion, and for the variance. After we see what hypothesis testing is about, we are going to see what's the connection between hypothesis testing and confidence intervals. So we have that. We have seen that the confidence interval is an interval in which we estimated the value of a parameter with some confidence. Now, what we are going to do in hypothesis testing is to test a parameter about its value. So, what happens is that actually we have some knowledge, or we think that the parameter may or should take a value, and we want to test if actually the sample we have comes from such population with this specific value. So, we have to, in order to do hypothesis testing, we have to define the null and the alternative hypothesis. We are going to see later on exactly what the null and alternative hypotheses are. Then we have to decide if the test is one or two-sided. We are going to see this as well, what it means. We have to calculate the test statistic, which usually it estimates the parameter, and it's usually the one that we have used for confidence intervals as well. And finally, we are going to make a decision about our hypothesis. Let's see an example and see how we can construct a hypothesis testing. Here we have the average number of sales at a store of a particular product is 50 a month. The company tries a new method of advertising for 10 months and wants to see if there was any increase in the sales. So when we have problems like this, when something is changed and we want to see if there is going to be an effect somewhere, we do hypothesis testing. Here we test if there is any effect in the mean value. So it's testing for the mean. The question we have asked for this example is if the average number, the mean of the sales, has increased. In other words, we have asked, writing it with mathematics, we have asked if the mean value is greater than what it was before, is greater than 50. Now, the null hypothesis is usually a statement declaring that nothing has changed from what it is known. So, as we said before, the first step in hypothesis testing is to define the null and the alternative hypothesis. As we said here, the null hypothesis will be that nothing has changed from what it was known. So from the example we have seen, the hypothesis that nothing has changed is actually, writing it with maths, is actually that the mean is 50. It has not been changed. Now the null hypothesis is denoted with the letters H naught, which means it's the capital letter from hypothesis, and it is the null hypothesis H0. The alternative hypothesis will be the statement that we want to test from the data if it is true. So what are we asking? What do we want to find out? In this example, we have asked if the mean value is greater than 50. It has been increased. And the alternative hypothesis is denoted using the capital letter H with 1, a subscript 1. Now we have to decide, the second step we said is to decide if the test is one or two-sided. Now for this particular example, we are interested in detecting only if there is an increase in the sales, not a decrease. So if there was a decrease in the sales, we are not interested. We are going to use our old method. But if there is an increase, the company is interested to find out to use the new method. So we see here that we are actually asking a one-side question. We are only asking if the mean is greater than 50 and not if the mean is less than 50. If we're asking, if our alternative question was that the mean is not equal to 50, which this would mean both a question that the mean is not equal to 50 is translated that is less than 50 or greater than 50, both of these and not one of these two, then we would have a two-sided question, a two-sided hypothesis. So hypothesis with the alternative only greater or only less, the less sign, it's a one-sided one, and the not equal is a two-sided. So we understand that for our example, we have a one-sided hypothesis. Now, most of the times, if it is not clear that we want to have a one-sided hypothesis, we would use a two-sided. So then we calculate the test statistic. As we have said, usually is the same one as we have used for the confidence intervals. And this, as we have seen, can be calculated from the data and will measure the compatibility between the null hypothesis and the data. So it will measure if our data come from a population for which the null hypothesis is true. Now, we finally have to make a decision based on evidence from the test statistic. So having calculated the test statistic, we can then make a decision if we should accept or reject the null hypothesis. Now, let's have a look at what happens when we do a hypothesis testing. As we have seen in confidence intervals, we had a confidence level. The same thing happens with hypothesis. Let me remind you that when we're looking at confidence intervals, we're looking at 100 times 1 minus a % confidence interval. Let us note this a here and see what it means for hypothesis testing. So we have that A for hypothesis testing will actually be the type 1 error, will be the probability of rejecting the null hypothesis when it is true. So let's see an example. If we had a 90%, for example, confidence interval, our A, if we calculate from here, will be 0.1. So we have 0.1 probability of a type 1 error of rejecting the null hypothesis when it is true. We are going to make a graph to understand this. So A, as we have said, will be this area here, is the probability of actually rejecting our hypothesis, although we are still in the population, we are working with a population that comes from this distribution. Our null hypothesis is true. Now, in hypothesis testing, we have another type of error, which is related with the type 1 error. We have the type 2 error, and is the B, which is the probability of accepting the null hypothesis when it is false. Let's see how the two types of errors are connected. Now, the first distribution here would be, let's say, from a population for which the null hypothesis is true. And here, the second distribution would be for a population that the alternative distribution would be true. So what happens is, by choosing A, by choosing, let's say, A to be here, this area, we actually have chosen B to be this area here. So the smallest we make A, the larger the B is. So we can understand that by gaining in one side, we are losing in the other. So if we want, for example, to be correct more times when the null hypothesis is true, rather than be correct when it is not true, we need to choose in the proper way A and B. Let's make a graph to do this in more detail to understand what's happening. So, as we said, we have the distribution of the population if the null hypothesis is true. We said that we are choosing A to be this. A is the probability of rejecting the null when it is true. So it is obvious that we would like A to be as small as possible, not to make an error. But if the population does not come from a distribution like this, but comes for a distribution like this one, then what we have done is that we have actually failed to reject the null hypothesis in here. This is area B. We have actually failed this in this area, in this part here, or this part would be the area that we failed to reject the null hypothesis when it is false. Gaining one side, we're losing the other side. So we have to be careful how to choose A. Now, let's see how we can do hypothesis testing for the mean when the sample is large. We are going to see that actually we have the same categories as we had for confidence intervals. So the statistic to be calculated is given here, is the sample mean minus the value that we want to test that our mean is. So actually what we have is that the null hypothesis will be that the mean of the population is equal to some number, and now it depends what our alternative is. If the alternative is less, greater, or not equal. We can have three different cases. We are going to see how for each case we can make a decision. So our table here has three cases, as we said, has the one-sided for testing greater than, one-sided for testing less than, and the two-sided. Having calculated this statistic, which is a number, we are going to get a number. What we do is that we compare the number we have obtained by the point of the normal standard, normal distribution of area A. So if Z is greater than this, we reject the null hypothesis. If Z is less than this number when our hypothesis is here, we also reject the null hypothesis. If we have a two-sided problem, then we reject the null hypothesis if we see here an absolute value of Z is greater than this value. We note here that this is half of this. And this is because here we have in the one-sided, as we have seen, we have one side in the distribution. Here our area becomes half one side and half the other side. Now the letter we use here, and for all statistics that we are going to see, we'll see that we actually use letters that are the same with the distributions that we use in order to make a decision. So the letter Z doesn't have to do anything with the distribution. It's just that it's for our help to use the same letter as in the distribution here in order to remember which distribution to compare with. Now, here we talked about variance when the variance is known, when the standard deviation is known. When the variance, the standard deviation, is unknown, then we can use the same statistic as here, but we need to replace sigma by S, by the sample variance, by the sample standard deviation. Let's see an example. Here we have data. We have the time of normal operation of a network. Can we assume that the population has been 2000? Can we assume that these data come from a population that the mean is 2000? Our sample size is given to be 45, and also the sample mean is given to be 1762, and the sample standard deviation is 215. Let's see how we can work this problem. Now, what we have is that we always need, when we start to write hypothesis testing, what is the null hypothesis and what is the alternative. Now, the alternative here, we are going to use a one-sided alternative to see how we can work with one-sided. But as we have said, if we cannot say clearly if we need a one-sided or a two-sided, we would better use a two-sided. For this problem, we are going to work with one-sided to see how we can make calculations, but from now on we're going to use two sides. Now I'm going to use ls, and let's choose A to be 0.05. What we would need to do is construct a table which will include our statistic, then we'll include the value of the distribution for which we are testing the population, and then we are going to make our decision based on what we have here. So we calculate our statistic. We have all, we don't have the standard deviation, but we have the sample standard deviation, so we can use the formula as we have seen, replacing sigma by S. And we calculate, I'm not going to make the calculations here, just give the result, is minus 7.43. Now the distribution has 1.65. And now, based on what we have calculated, we can make our decision. So we have that, as we have seen, actually this is less than the negative number, than minus 1.65, and so we reject our null hypothesis. And so we can say that the population actually, based on the data, does not have mean equal to 1,000. Now we are going to see what happens when the sample comes from normal distribution. The sample size is small this time, and the variance is unknown. As for the confidence intervals, we remember that instead of the standard normal distribution, we would use actually the t-student distribution. And the test statistic is the same as before, but instead of the sigma, the variance, we use the sample. Instead of the standard deviation, we use the sample standard deviation. So for one-sided, again, the three different cases as we have seen before. For one-sided testing, if mu is greater than the value we have, we reject the null hypothesis if our test statistic is greater than the value of the distribution. N minus 1 degrees of freedom. We remind here that t-distribution has some degrees of freedom. For one-sided, for the less test, we reject the null hypothesis if t is less than minus the point of the t-distribution. For a two-sided, again, we take the absolute value of our statistic and we compare it with the point of the distribution. If it is greater, we reject the null hypothesis. Let's see again an example. So this time our data are that a company paid some commissions to 6 employees. Last year the average commission paid was 1,600. Has the average commission changed? We have seen this example when we constructed confidence intervals, and now we can see how we can make hypothesis testing. So what we have for this data is that, first of all, we need to write our null and our alternative hypothesis. The null hypothesis is if the mean value is 1,600, and the alternative in this case, as our question is not if it has increased or if it has decreased, we have no evidence of deciding on one side, we are going to use a two-sided. So our alternative will be if the mean value is different than 1,600. From our data, we can calculate the sample mean and also the sample standard deviation as the variance is unknown. The standard deviation of the population is unknown. As before, we are going to construct our table, which will consist the statistic, the value of the distribution. Let's choose A equals, for example, 0.05. We use this a lot because it's actually the point most people use, and it's a two-sided, so we are looking at 0.025 at A over 2, and we're going to make a decision based on what we're going to calculate. The statistic can be calculated is 0.27 based on our data, and the point of the distribution is 2.571. Now, according to what we have calculated, we see that the absolute value of the statistic is actually less than the point of the distribution. So we have that. We accept our null hypothesis. We can say that the mean value is 1,600. Now, of course, because our sample was small, we needed to assume that the population follows a normal distribution for this example. We have said when we saw this example in the confidence intervals that we are going to make this assumption. It is reasonable to assume that not a lot of people are going to get very high commissions and not a lot of people very low commissions, and it's going to be an average number around which all other numbers are going to be normally distributed. Now we are going to see hypothesis testing for proportion. When we want to do hypothesis testing for a characteristic in a sample, when the sample is large, we have that here. Our statistic, we see that can be calculated from this formula given here. If we have a one-sided test, we are going to reject the null hypothesis again the same way as before. We see actually that for all tests, the only problem is to decide on which statistic to calculate, know which distribution we have to compare with, and then actually it's similar for all tests when we reject for each case. So we see as before the one-sided greater, the one-sided less, or the two-sided what's happening. So if we have data now from 100 students that are asked if they are left-handed or not, and it is generally known that 90% of the population are not, we want to test if this is true, if actually the sample comes from such population. We see that we know something, we have some information, and we want to test if this information is true or not. So we collect data. We have 14 positive answers out of 100. So our test statistic here, we see that actually the estimate of the population of the estimate of the proportion is 0.14, and we are going to calculate the test statistic. Here it's, as we have seen, slightly different than the estimate, and we are going to do our test. So we have that. For this example, our null hypothesis is that the proportion is 0.1. Our alternative is a two-sided. We have nothing to tell us that test one side or another, so we test a two-side. We use a two-side test. Again, let's choose A equals 0.05, and in the same way as before, we construct our table consisting of our statistic, the value of the standard normal distribution at 0.025, it's a two-sided test, and finally making the decision. The statistic here, we said it's not the estimate in this case, it's slightly different. It's calculated to be 1.33. The point of the distribution we already know from our previous example. And based on these numbers, we see that the absolute value here is less than this, so we accept our null hypothesis. Now, what happens with the variance? We want to test the hypothesis that the variance comes from a population with a specific value when the sample comes from normal distribution. Now we have to use a chi-square distribution here, so we are going to use the letter x squared for our statistic, which can be calculated from this formula here, where this number will be the value that we are testing the variance for. Again, the same way, 3 cases, one-sided, each side, and a two-sided. We are careful here. We remember that chi-square is not a symmetric distribution, so we don't take absolute value as before and compare, but we have to calculate 2 different values here and compare with 2 different values and make our decision based on this table here. Let's see an example for this problem. We have the company paid commission to 6 employees. Is it reasonable to assume that the data comes from a population with variance 750 squared? The data are given in this table, and we calculate our test statistic to see what's happening. What we have here is our null hypothesis, as we said before. 750 is the variance. Our alternative hypothesis will be that is not equal. We are testing for not equal, a two-sided test. From the data, we have calculated that the sample mean is given here. The variance also calculated from the data by choosing a 0.05, we can construct our table. So we have the statistic. Now, 2 values we said we need to calculate for our distribution. This is a over 2, and this will be 1 minus, as we have seen, a over 2. And finally, we need to make a decision based on this. The statistic, if we do the calculation, is 6.27. Now these values can be read from tables. And as we see that this value is between this, is greater than this and less than this, we can make the decision that we accept our null hypothesis that the variance, the sample, comes from a population with variance 750 squared. We're talking about the variance, not the standard deviation. Now, because the data, the sample size was small, we could actually do this test assuming that they come from a normal distribution. So they come from a population that follows a normal distribution. Now we have seen about hypothesis testing. In our next lesson we are going to continue with hypothesis testing when we have two samples, when we have two populations. So in this lesson we have seen hypothesis testing for one sample, for the mean, for proportion, and for the variance. For more information on this lesson, you can visit the website of UNINETTUNO MedNetU project.